Right, well, welcome to IWM Duxford's Summer Air Show, mainly celebrating things American. This is entirely not American. This is an Anglo-French concoction, Concord. And this Concord and all the airliners here belong to a group called the Duxford Aviation Society, a partner of the Imperial War Museum. This particular Concord is a pre-production one. There was one owned by the British government, this one, and one owned by the French government. And in the first part of the 1970s, they did 5 years of very extensive and quite scary trials and developing certain things, including the nose droop, which we'll demonstrate in a bit. Our pilots today are Simon, the Englishman, and the other side should be Charles, our French pilot today. Hopefully they've got all the things sorted out, ready to go. What we're going to do now is pretend to fly from Heathrow to New York and demonstrate the various stages of the nose droop. The most interesting one is when we get to New York, so don't buzz off early. Right, so we're going to New York, we're at Heathrow. The pilots have been on board about an hour. We've taken on 100 passengers, 90 tons of fuel, and we're ready to start our engines. So to signal they're ready to start the engines, and they're done from a vehicle on the ground. Because we're ready to start the engines, we're going to put the anti-collision lights on. And if you can see where the wings join the fuselage, they should start flashing. And on the wingtips, the navigation lights come on. Right, they're ready to start the engines. 2 of the engines will be started, and then they're ready to push back, ready to go, and they start the other 2 engines themselves. Only thing is they can't see where they're going because of that nose. So what they're going to do first is lower the heat shield visor. Now with that down you can see the actual cockpit window, but they still can't see the yellow line to follow to the runway. So to taxi out the runway, the nose goes down to 5 degrees. And like that, they can taxi out to the runway, and when they're ready to go on the runway, they're going to put their landing lights on, which come out of the fuselage further down, they're very sleek, they're recessed, and they'll put the taxi lights on, which are on the side of the cockpit. And once that's all done, they go onto the runway, and they're ready to go. Now, if we were in a conventional airline, like a Boeing or an Airbus, we'd calculate the throttle settings. Concord didn't start with that. All 4 throttles go to maximum, and away she goes. At about 70 miles an hour, something called the reheat, or the afterburners comes on. That's raw fuel injected into the exhaust, and you used to see planes coming out the back of Concord. If you were a passenger in it, you felt the thump in the back as they started. It really accelerates. And it carries on along the runway until it's going faster than a Formula 1 car, about 255 miles an hour. It lifts off and climbs away. The reheat is still on for about another minute, and then we cut it because of the noise. And now we're going to get the plane a bit more streamlined, so we're going to take the nose back up to 0 degrees. And then that heat shield visor comes up. And at the same time, the pilots will turn off the landing lights and taxi lights. Thank you, guys. And like that, we're going to carry on climbing as fast as we can, but just keeping below the speed of sound, heading out for the Bristol Channel. It takes about 19 minutes. Once we're over the water, we go back to full power, and the afterburners go back on, and it climbs away. Once it gets to about 1.7 times the speed of sound, the afterburners are no longer necessary, and it carries on climbing until it's about 60,000 feet. And that's 20,000 feet or more higher than the current Boeings and Airbuses fly. We go across the Atlantic at Mach 2.23. This is the fastest Concorde. If you want it in miles per hour, that's 1,460 miles an hour. That would get you from here to Heathrow in less than 2 minutes, well less than 2 minutes. The airline Concords, though, didn't go as fast, because what the engineers developing this plane found was that it gets incredibly hot. it actually expanded on a transatlantic flight by about 10 inches or 12 inches because of the heat. And they figured out that if it carried on getting that hot and was an airline plane, the service life of the metal would be lower, so the airline once went 100 miles an hour or so slower. But we were whizzing across the Atlantic much faster than the other planes. 150 miles from the coast of the United States, we're going to start slowing down. It takes us 100 miles to bleed off the speed and be subsonic so that we don't annoy the Americans with an sonic boom. And we're getting ready to come into New York's JFK Airport. As we're approaching the airport, we start improving our visibility, and first we are going to put down the visor, the heat shield visor. And then we put the nose down to 5 degrees, the taxi position. But now we have a problem, we can't see the runway. I have this elaborate software model. Boeing or an Airbus will come at about an angle like that, but Concorde uses its big wings to slow down. It's going to come in like that. So even with the nose down to 5 degrees, they can't see where they're going. And this was the one that developed how far down does it need to go. And what we'll demonstrate now is a 17.5 degree nose droop. Now this is the droopiest of all the Concords, because whilst the pilots can clearly see the runway here, they have no point of reference, the nose has gone completely out of sight. And when Air France and British Airways pilots started training on this plane, they were a bit unhappy they couldn't see the nose, so this was used to find the optimum position where you could see the nose but still see the runway. And we'll show you now the other setting that the airlines used of 12.5 degrees. So like that, that's, if you saw a British Airways or Air France Concorde landing, it would look like that. But because we've got the droop its nose, we're going to lower it back to 17.5 degrees for our landing. And because we're landing, we're going to put landing lights on and the taxi lights. Even if it's daylight, we need to be seen, particularly around New York Airport. There's a lot of general aviation traffic. So in that configuration, we land a lot faster than the Boeings or Airbuses, about 50 miles an hour faster. It was the first plane with carbon fibre brakes, so it could stop quickly, but they created a lot of heat, so the brakes are electrically fanned to cool it down, and it manages to stop quicker than the other planes, and then off it goes on the taxiway. So as we're taxiing, we're going to put the nose back up to 5 degrees. So like that, they can follow the taxi line to the terminal building and connect to the air bridge. Once they're connected to the air bridge and the passengers are coming on, they're going to start cleaning the plane up. They're going to take the nose up to 0 degrees so it looks nice and elegant. They're going to switch the lights off, the landing lights and the taxi lights. And then the heat shield visor goes on. So that's it, folks. Welcome to New York. When you go outside, you might think it looks a bit like Duxford, but enjoy your day. Thank you very much.